So the basic setup of a loss aversion model is that the utility contains a part. So I want black. So a loss aversion model. So the basic component is, for some of the goods in concern, there is a utility that depends not just on the amount consumed, but also on a reference point. Okay, so the V function represents loss aversion, and CI is consumption, and the RI is the reference point. So consumption of good I, and RI is the reference point of good I. We haven't talked about how the reference point is determined. In this particular case, the question actually tells you what to use. But in general, you can consider this as the status quo. That is, your reference point is what you have right now. So if you have $100 in your pocket, that's your reference point for now. Okay. So the V function is the loss aversion function. Right. Typically, for simplicity, you would have something like the V function being just simply x for x bigger or equal to 0, and 2x for x smaller than 0. Now notice that this is a stepwise linear function. Namely, it looks like this. This is V. This is the plus positive range. This is negative range. Remember, we just recall that prospect theory have three parts: loss aversion. You have the risk aversion in the gain domain, risk loving in the loss domain, and probability weighting. This particular function only captures loss aversion. Okay? It only captures loss aversion. This makes it a lot simpler to do as a demonstration and then or in assignments. If you have to include probability weighting as well as the what we call diminishing sensitivity, the functional form will be a lot more complicated. And for 80% or 90% or even 90% of the insight from prospect theory comes from loss aversion. So focusing on just loss aversion makes sense. So there's no probability weighting and no diminishing sensitivity. Okay. All right. So in this question, okay, so it says that there's this individual, Aversion, who has reference-dependent preference over money initially. All right. So the first good for this person is money. C1 represents money. R1 represents his reference for money, which is at the moment 0. All right. And then part A says that Aversion has just agreed to take part in an experiment, and he was told by the organizers that he might receive $10 for his participation. Suppose he can choose whether to incorporate the $10 into his reference point. Calculate his utility with a reference point of 0 and a reference point of 10 if he received $10 for his participation. Calculate his utility with a reference point of 0 and a reference point of 10 if he receives nothing. Which reference point use a higher utility, and explain the intuition. All right. Now, so part A is might sound like a strange question. Which reference point to choose? Which reference point to choose? Now, it's a bit strange because you might think that, well, you shouldn't be able to change what your reference point. It's what you have right now. So we'll explain why there's such a possibility later on. But for now, let's just ask: is it better off having a high reference point or a low reference point? So let's consider expect nothing. He gets $10. What is utility? His utility would be fee 10 minus 0, which is 10. And if he expects $10, get $10, his utility equals to fee 10 minus 10 equals 0. All right? So the first observation is earning money does not necessarily make you happy if you expect to earn that amount to begin with. Okay? So it makes a lot of sense because you think about it. In the society, there are vastly varying salary, right? You have people in Hong Kong in particular. You have the average where the median salary is about just $10,000, slightly more than $10,000. Yet you have, if you are working in medicine or law, you earn like 7 or 8 times more than that. Yet you don't see people being many times happier for earning such a high salary, right? Because they have come to expect this salary. So if you give someone who's earning $10,000, perhaps like $5,000 more, he's going to be very happy because he's earning more than he expected, right? But as a person who is already earning $15,000, giving him $15,000 doesn't make him particularly happy because he expects to earn that much, right? So earning what you expect does not make you happy. Okay, now the other case, expect 10, gets nothing. So the utility in this case is fee 0 minus 10. Remember, in the negative range, the fee function is 2 times x. So this is negative 20. And finally, expect 10. Oh, what is it? Oh, yeah, expect 0, get 0. Not expect 10. Expect 0, get 0. Utility equals to fee 0 minus 0 equals 0. All right? Now, 3 and 4 shows you that if you expect to get money and you're not getting, and you don't get it, it actually makes you very sad. Okay, losing money is a lot more painful. That's the idea. But if you expect nothing and you get nothing, it feels like nothing because it's not yours to begin with. So now if you look at these 4 cases, it starts to make sense to think about what reference point the individual wants to have, right? Because if he comes in with an expectation to earn something, and in experiments typically you're not guaranteed to earn something, you're going to go away disappointed. More importantly, sometimes your expectation would affect your behavior. If you expect to be, you only buy stocks if you expect to make money, right? If you don't expect to make money, you're not going to do it, right? So if you buy stocks if you expect to earn, and you don't buy otherwise. And we'll see that in some cases, you have self-fulfilling prophecy. So you're self-fulfilling prophecy. If you expect something to happen, it does happen because you do it. And if you expect something not to happen, then it's not happen because you don't do it. And for that reason, we would like to think about what reference point makes more sense. Okay. All right. Now, so we'll think about this later on. For the rest of the question, most of the time you're given the reference point. So now suppose Aversion has a reference-dependent preference, not just over money, but over money, mucks, and pence. Let his consumption in money, mucks, and pence be C1, C2, and C3 respectively, and his reference point in money, mucks, and pence be R1, R2, and R3 respectively. Then his utility is, so from now on, his utility is going to be, or just for now, so now on, utility equals to phi C1 minus R1, so this is money, remember, plus phi 4C2 minus 4R2 plus phi 4C3 minus 4R3. Now, so the utility has three components. Money, C2 is mucks, and C3 is pence, right? So this is the setup that mimics the experiment we talked about last week. They come in, they can earn, they show up, usually in an experiment. When you show up, you receive some money. So that's the participation fee. In Hong Kong, usually when you participate in an experiment, you get $50, 50 Hong Kong dollars. That is the typical salary, hourly rate paid to students by the university. So you're usually paid in the hourly rate for a student helper in an experiment. Then in the experiment we talked about, people were given mucks or pence, or mucks or candies in that case. But in this case, this is muck or pence, and they can exchange, right? So part B says that Aversion arrives at the experiment and getting $8, which he does not expect. So he does not incorporate into his reference point. So what this says is that C1 is going to equals to 8. C1 is equals to 8. And R1 is 0. So he's getting money that he does not expect to get. He's also given a muck. So 1 muck, which he does not expect to, which he does expect to have. Okay. Which he does expect to have. So perhaps he was told that he will get a muck, or perhaps so the muck is already in his hand. So, and he already feels like it's his. And it doesn't say that he has any pence, so we'll assume that he has no pence. Okay. Okay, so we assume that he has no pence and he doesn't expect any pence. Okay. The question asks you to write down what's the amount he would be willing to sell his muck for. Okay. So we need to find selling price of muck, PS. So as in typical microeconomics, you find PS by finding the amount that would make him indifferent between having the muck but not having the extra money versus having the extra money and not having the muck. Okay. So you need utility of selling equals utility of not selling. So this is just typical microeconomics. And if he sells, he gets fee, no muck, which he expects to have. Oh, sorry, this is money. This is the first money, sorry. Okay, so start again. Okay, so first money. Okay, so we already know he has $8 he doesn't expect to have, plus he's now selling his muck, which gives him PS. He's not going to, neither of these he expects, so the reference point is 0. Plus, he is going to sell his muck, so he's going to have no more mucks. And he does expect the muck, so he has a reference point of 1 for the muck. And finally, he has no pen, so that doesn't really matter. And he doesn't expect any anyway. This has to equal to the utility of just having the $8 that he doesn't expect. That's the experimental participation fee, plus having the muck, which he expects, and not having any pens. Now, in the future, in subsequent questions, I'm probably going to skip the pen part because it doesn't really do anything for now. All right, so you can solve for this. So money is positive, so it's just 8 plus PS. Muck, the muck part is negative, so you have to times 2. You have to times 2. Equal, money part is positive, 8, plus the muck part, which is actually 0, so just 0. Right. So solving for the selling price, this would be $8. Okay. Okay. This by itself is not particularly meaningful until you solve for the buying price. Okay. Until you solve for the buying price, then you can see that they're going to be different. So part C asks you to find the buying price. So part C says that suppose he doesn't have the muck, so C2 equals to 0. All right. Now, one question that is not very clear in this case is whether, for part C, it doesn't actually explicitly say that whether he has a reference point for muck or not, okay? Because the question doesn't say. So the answer would be different depending on whether you interpret the situation as he was told that he can get a muck. He arrived not having and find out that he wasn't given a muck, or whether you believe that he wasn't expecting a muck, but when he has the muck in his hand, he would come to feel a sense of ownership, which gives him a reference point of 1. Because if he arrived, in that case, if he arrived without being given a muck, he won't have a reference point for muck at all, right? So it doesn't say here. So we're going to assume that he doesn't expect a muck. Okay? We're going to assume that he doesn't expect a muck. So we're going to say R2 equals 0. Okay. So in this case, what happens? Now you want to see whether he's good. At what price would he be willing to buy the muck? So once again, you need, as in standard microeconomics, you need the utility of buying equals not buying. So what you have is V $8 minus the buying price plus utility of getting a muck that he does not expect. Now, as I said, I'm going to skip the pen part because it doesn't do anything. Has to equal the utility of having $8 not buying anything. Oh, so I forgot to reference point. The reference point is 0, so that's why I forgot, because it doesn't do anything here. Plus not having a muck that you do not expect anyway. So what is that? Now, technically the price could be bigger than $8, which would bring the first V to the negative range. But we'll just assume that it's not going to be the case, and you see that it's in fact not going to be the case. So we're just going to say it's going to be 8 minus PV instead of 2 times 8 minus PV plus having a muck that you do not expect. So it's just 4 times 1 has to equal money he doesn't expect, $8, not buying anything, plus not having a muck, so he's not losing anything. So rearranging gives you the buying price equals to $4. All right. So this is the endowment effect. If you ask him to buy a muck, which he does not expect to have, he's only willing to pay $4. But if you ask him to sell a muck that he already has, then he wants $8. That's the endowment effect. People appear attached to what they have. So PS bigger than PB, and this is the endowment effect. People are attached to what they have, so they want a higher price. What's interesting is that in this market, if the market price, like if this is actually a big market, and the market price is something like $6, Aversion would neither buy nor sell, which typically, if you think carefully, typically do not happen in a classical microeconomics model. In a classical microeconomics model, your buying price is the same as your selling price. So if you think about the market price as having a range of possibilities, the chance that you are neither willing to buy nor willing to sell is minimal. It's minuscule, right? Because if the price is moving around randomly, just like in the stock market, the chance that it will exactly land in your reservation price, it's very small. So at any given moment, you should be either willing to buy or willing to sell in a classical economics utility model. But if you observe the reality, most people do not do that. Even for very expensive items, which the transaction cost is not an issue. Most people do not engage in constant transaction. So this would be one reason. People have lower willingness to buy than their willingness to sell. Yeah. So they're not willing to buy. So this is the endowment effect. And then part D says, argue briefly that Aversion's buying price and selling price for pens are the same as for mucks, which is easy because the utility function looks the same. All right, for the rest of the question, suppose that Aversion has two options in the experiment, to buy a muck for $7 and to buy a pen for $6. So this is E. So mugs cost $7. Pens cost $6 each. Right? So suppose a burro arrives at the experiment with a reference point of having 1 mug and 1 pen. Perhaps because he was told he could get these as gifts, right? So this time, the question clearly tells us the reference point is 1 mug and 1 pen. So R2 equals to 1, and R3 also equals to 1. His reference point in money is still 0, so R1 is 0. And he still received the $8 show-up fee, so C1 is 8. Now the question asks, would he buy a mug for $7 if that was the only choice he was offered? This is actually 3 questions. Would he buy a pen for $6 if that was his only option? Would he make both purchases? Briefly explain tuition. Actually, it's 4 questions. Would he buy a pen? Would he buy a mug? Would he buy both? And why? Okay. So this is kind of cheating. This is what you want to do. You want to trick people to believe there's only one part. So when I was studying for my PhD, so one of the teacher I worked for, her final exam only had like 1 question with N parts. I think A, B, C, D, E, F, G, H, I, J, K, L, M, N. 13 parts. So it's actually harder to do than if there were multiple questions, because it's all part of one big question, which means you can't proceed unless you solve the previous part. All right. So in this case, we first would he buy a mug, right? So once again, you need utility of buying equals utility of not buying. So for the subsequent part, I'll skip this step, skip this line too, since you now know what we need to do. Okay, so he comes in getting $8, not expected. He pays $7 for the mug. His reference point is 0. Plus, he's now getting a mug, which he does expect. So you have to subtract the reference point. He also expected a pen, but he is not getting any. Versus, if he comes in not buying anything, which means he's not getting anything despite expecting both. Right? So you can calculate this would be he gets $1 in extra than he expected. He gets a mug that he expected. He's not getting a pen that he was expecting. And that has to equal to the case when he's not buying, then he gets $8 unexpected, losing a pen that a mug that he expected. Well, I mean, not getting a mug that he was expecting to get, and not getting a pen that he was expecting to get. Okay, so actually, I shouldn't say equal. That's not right, because we are actually asking whether he's going to buy or not. Sorry. So I should say more like this, right? Okay. All right. So on the left-hand side, you get -7. And on the right-hand side, you get 8 minus 8 minus 8. So that's minus 8. So clearly the left hand side is bigger, right? So yes, he's going to buy. Since utility of buying mark is bigger than utility of not buying, a furrow is going to buy the mark. Okay. So what this shows is that if someone comes in expecting something and not getting and end up not getting it, there's a very strong incentive for him to pay his way to get what he expected. Okay? So if you think about investment, when people, if you think about let's say the reference point being a particular price, or being a particular price that you purchase a stock at. As the stock, if the stock loses value, if the stock end up lower than what you expect, there's a very strong incentive for you to try to hold it on until you get your way back. So not getting something you expect is a very strong incentive for you to pay your way out. You're actually willing to pay a cost so that you can achieve what you expected. All right. So now, we're actually going to skip this buy pen part, because actually, if you do the math, it's going to come down to -6 bigger than -8, because the only difference between pens and mugs is that the $1 price difference. So he's going to buy pen too. So what we actually want to know is whether he's going to buy both. Okay. What would he get if he purchased both? Now notice that if he does purchase both, he's going to enter into the negative range in terms of money, because he has to pay $13 in total. So he only has $8. Okay, so he's going to get a pen, he's going to get a mug, but he's going to lose money. Right? We already know if he does nothing, he's going to get -8. So let's skip that. So he's going to mainly he's losing out at the money side, and that's 2, 8, 16. 16 minus 6. Yeah. So it's 8 minus 13, so it's -5. So 2 times 2 is -10, which is more negative than -8. So no, he is not going to buy both. Okay. So the intuition is he is willing to forego some unexpected gain in money in order to avoid the sense of loss in mugs or pens. But if you ask him whether he wants to buy both, then he's not going to do so, because although he can avoid the sense of loss in mugs and pens by buying both, he's going to feel a sense of loss because he needs to pay more than what he gets from the experiment. So he's out of his pocket, he doesn't expect that, so he feels a sense of loss, and he's unwilling to do that. Right? So now an insight in this particular part is that there's something called a house money effect. That is, if you go to, the behavior of actual gamblers is that they are very willing to gamble away the money they have earned during their gambling sessions. So you play, let's say you're playing jackpot, you earn a lot of money. Typically, gamblers are willing to put up all those money they have gained back into the gamble. So that's called the house money effect, because house money, right? It's the money from the house, right? You observe a similar pattern in stock market. People are willing to use the money they have earned in their investment for further investment. People are much less willing to pay out of pocket. So this is the house money effect. So much more willing to spend unexpected gain. Okay, finally, part F. Suppose a furrower can choose whether to enter the above experiment with a reference point of getting a mug or a reference point of getting a pen, knowing the price is in advance, but he cannot choose his reference point in money, which is 0. Which one would he choose? Briefly explain the intuition. Finally, the question asks is whether, knowing that the mugs are more expensive than the pens, would he be better off expecting to get a mug, or would he be better in expecting to get a pen? Now remember, this is a weird question. The way it works is, okay, you can choose whether you want to expect a mug or expect a pen. When you come to the experiment, you're not going to get it. So I think that's the point. That's the point. Yeah. You can choose whether you want to expect a pen or expect a mug. When you come in, you're not going to get it. As we just calculated, if a furrower expects something and not getting it, he's going to pay his way to get it. So this is really saying, should he expect himself buying a pen, or should he expect himself buying a mug? Now, knowing that mugs cost more than pens, is actually better off for him to expect a pen, because he's going to expect a pen, end up buying a pen. And if he expects a mug, he's going to end up buying a mug. So just briefly, if he expects a pen, he's going to buy a pen. If he expects mug, he's going to buy a mug. And since mug is more expensive than pens, expecting a pen is better. For a furrow. Okay, so once again, this is the case of self-fulfilling hypothesis. You expect a pen, you end up buying a pen. But if you expect a mug, you will end up buying a mug. So because you have multiple equilibrium in some sense, right? You have multiple equilibrium outcomes. Then theoretically, you want to have a sense of in which path the individual would choose. And rationally, it makes sense for the individual to choose the path that gives him the highest utility at the end. Okay. All right, so this is the math